I'm Anil Kumar. In this particular video, we'll understand how to write equation for polynomial functions when their characteristics are given to us. So we have two examples. The first one here, let me write this as question 1, is to create polynomial function with given characteristics, degree 4, x approaches infinity, polynomial approaches minus infinity, x intercepts at -6, 0, 1, 0 and 1, 1, 7, 0. The graph of y equals to p of x crosses x-axis at 1, 0. The second question for us is again to create polynomial function with given characteristics. The solution to f of x equals to 0 are x equals to plus minus 3, x equals to minus 2 and x equals to 4. The leading term is minus x to the power of 5. The point minus 2, 0 is the local maximum on the graph, right? So we have two different questions. I'd like you to copy these, sketch the polynomial and then write the equation, right? So that should help you. So let's take them one by one. So here is my first question. It says create polynomial function with these characteristics. We are given degree of 4, right? So as we read, I will actually also sketch it and then we are going to provide an equation for the same. So let's try to make a rough sketch here. Now this diagram is not to the scale, but it gives you the understanding of how to get to the equation. So degree 4, that means both sides face the same way. End behavior is x approaches infinity, polynomial p of x approaches minus infinity. That means going downwards. Now since it is degree 4, both will be going downwards, right? So that becomes your end behavior. Perfect. So combining these two, we get end behavior. Now, x-intercepts. X-intercepts are at -6, 1, and this is far away. So let's say this is my far away point. Think like this, a break here, right? Then we have 1 and -6. Okay. So these are my three x-intercepts. And that point is 1, 1, 7. Now it says the graph y equals to p of x crosses x-axis at 1, 0. So it crosses here, kind of like this. Do you see that? Let's say it crosses here, kind of like this. That's what it is. Find the equation. Now if this is the behavior, we are given three different zeros, degree is 4. That means one of them is of multiplicity of 2, correct? One of them is with multiplicity of 2. Do you get the idea? So that means we could sketch a graph like this. Think about the graph like this. I mean, if I consider this to be like this, we could, let me just show you here, right? So, do you see that? Does it make sense to you? So one graph could be like this, the other one could be, let me sketch the other one here, could be that we actually turn at this point. We turn at this point, right? And then we go kind of like this, and then like this. That is also possible, no? So giving us 0 here, which is the linear 0, it crosses and turns at -6 and crosses at 1, 1, 7. Do you see that? So there are two possibilities, and these two possibilities will give us two different equations. So let me write down one. So for p of x, I could write this equation as a could be anything. Let's keep it 1. So we could write this as x plus 6 times x minus 1 times x minus 117 whole square. Does it make sense to you? Since it is moving downwards, right, so leading coefficient has to be negative, so I'll make it negative. Correct? That's one. The other equation could be, I could write this as negative again, right? x plus 6 whole square, since it turns here, times x minus 1 times, x minus 117. Does make sense to you? You can see that the degree is 4. Leading coefficient has to be negative for the graph to turn. Perfect. If you write these equations, you can get that point also by finding the value of p of 0, right? Just select 0 here, get that value. You can select 0 here, get that value to be very specific also. But that is not asked for, right? At present, you could write any value here as a. So I hope the concept is clear. Some of you might just miss the second graph or one of them, right? So we are saying this is the polynomial p of x. So, and these are, there could be many options, right? But these are two different options with a different multiplicity or order of R zeros, correct? Now let's take the second example here, which says create polynomial functions with given characteristics. Solution is f of x equals to 0 or x equals to plus minus 3, right? X equals to minus 2 and x equals to 4. The leading term is minus x to the power of 5. So now we are talking about degree 5. Leading term negative means right side down. Odd opposite ends. This is important, correct? We are given the zeros at plus minus 3, so 2, 3, and 1, 4. So one of them have to be of order 2. Clearly, we are also given that the point minus 2, 0 is local maximum. So maximum means it has to turn kind of like this. Does it make sense to you? So at minus 2, so we have zeros at, let me make the zeros now. Plus minus 3 means we'll have, let's say this is 3 for us, and this is 2. And then we have plus 3 and plus 4. Okay, let's say this is plus 3 and this is plus 4. So these are the zeros for us, and the 0 which is at minus 2, one has to turn. Perfect. The others we do not have to turn. Others are linear. So now to connect, since we have to turn here, to connect we are coming from this side, so we'll just cross and turn here. So we could draw a graph like this. Do you see that turning? Does it make sense to you? And it meets the criteria for negative leading coefficient also. So this is the type of graph which you expect. So this is minus 3, minus 2. Those zeros are at plus 3 and plus 4. And clearly the equation in this situation will be what? In this situation we can write that the function f of x is equal to, now this is negative since it's going down, negative x to the power of 5. And let's write down the equation. X plus 3 gives us the first 0, the second one of order 2, which is x plus 2 square. And then this is x minus 3, and that one is x minus 4, correct? So in factored form, that becomes the equation for the function. Now, that is how we could actually write down the equation for the polynomials from the given condition. So I hope the concept is very clear. How do we get the equation from the graph? We can get multiple equations. This is kind of family, right? So family of curve. If we were specified a point, let's say y-intercept, we could have given specific equation also, correct? Now in this case that is not required. So in factored form that becomes the equation. So I hope it helps you to understand how do we get the equations from the given data. This could be written as x square minus 9. When you multiply these two, x plus 2 whole square times x minus 4. Okay. So anyway, even the earlier one was correct. So that is how you do it. So we'll take up more questions. Feel free to watch more videos on polynomials. Share your comments and views. If you like and subscribe, that'll be great. Thank you and all the best.